All right. Hello, everybody. My name is Leah Den Hartog. I am the editor of Plumbing and HVAC magazine. Today we have our lovely panel discussion. We will be focusing on how the A2L transition is impacting the whole channel from manufacturer all the way up to reclamation. So I've introduced myself. Let's have an introduction to each of the people on the panel. And each of them are going to tell them your name and their job title, who they work for, and then I'm going to ask each of them to also answer the question as to how does your company specifically work with A2Ls? So I'm not assuming, I don't know if you guys are in the same order on my screen as in yours. So let's start with Chuck.
Sure. Thanks. And thanks everybody for joining us today. My name is Chuck Allgood. I'm a chemist by training. I work for the Chemours company. We were spun off from DuPont, so we're the inventors of Freon about 100 years ago. I have about 35 years in the refrigerants industry. So I've been through a few transitions in the past. Many of you probably have as well. Where Chemours as a chemical manufacturer fits in this A2L journey, we're probably at the very beginning of the process. Maybe the only people ahead of us are the people making the regulations, because they kind of set the goals that we have for new refrigerants, new generations of refrigerants. And then early on, we work very closely with our OEM equipment makers as they design the equipment, and we kind of match the fluids to the equipment needs. That's a little bit of an iterative process, making sure we have the proper performance in terms of cooling capacity, energy efficiency, and we develop and provide a lot of thermodynamic basic data, transport properties, do a lot of toxicity testing of new refrigerants, all the way through. This is kind of behind the scenes before you actually in the field actually see them, and then they're commercialized, and then we follow on with a lot of technical support in the field, training, that sort of thing. Thanks.
Wonderful. Thanks, Chuck. All right, Devin, go ahead.
Yes, I'm Devin Thomas, the General Manager, Refrigerant Services Inc. So we're at the other end of the spectrum. So where Chemours starts, we finish. So we are Canada's first and largest reclamation center for surplus refrigerants. So we would be in our step in the process would be disposal and reclamation of A2Ls once they start coming back to us, which they already have to some degree. We would be disposing them into the RMC program or our own program, or most likely trying to reclaim products, as that is the most environmental, the best environmental choice for used refrigerant. So yes, that's what our role is.
Wonderful. All right, Victor, yours turn.
Hi, good afternoon, everybody, and thank you very much, Leah, and the team at Plumbing and HVAC for putting this together. My name is Victor Hyman. I'm the Executive Director of Climate Care. We're a cooperative of residential HVAC contractors in Ontario, and we're stuck in between Charles and Devin, dealing with with refrigerant. So excited to be here today, really to learn along with you about what we should be doing through the lifespan of the refrigerant.
Wonderful. Thanks, Victor. All right, Trevor, you're up.
What's up, everyone? Trevor Matthews here, Refrigeration Mentor. We're a technical training organization, so we train technicians and contractors all over the world. We specialize in commercial refrigeration, so supermarket refrigeration, condensing units, CO2. Super excited to be here today because I do a lot of training on A2Ls and A3s. After this session, I'm going to be doing another one on servicing commercial refrigerations with A2Ls. Super happy to be here. I see a bunch of familiar faces in the audience. Always good to see, and I'm looking forward to this panel.
Thank you very much, Trevor. And then last but not least, Maxime, go ahead.
Thanks, Leah. So hi, everyone. My name is Maxime. I work for Wolseley Canada. I'm the refrigeration manager. I'm located in Quebec, in Montreal, to be more precise. So Wolseley is a coast-to-coast distributor of HVAC and plumbing, the biggest in the country. And it's going to be a pleasure talking with my colleagues here and informing you guys on the A2L transition. Thank you.
Thank you. All right. So I don't know if I've already said, so I'm going to say it again if I haven't. For everybody joining in, we're hoping to make this as much as a conversation as possible. So now that we know who's going to be on the panel, we have some really great experts here today. So make sure you ask your questions. We're going to answer questions throughout the actual panel discussion today. And then if we'll also make sure that there's time at the end of this presentation as well to answer any of your questions as well. So I have prepared some questions, so we're going to start with these, but please let's try and stump some of these experts. Let's try to get as many good questions out as possible. All right, so first I'm going to aim it at Chuck. All right, so our first question is, what are some of the differences that those in the industry need to know when it comes to A2Ls like R32 and R454B compared to HFCs like 410A?
Yeah, great question to start off. The obvious answer is the flammability characterization is different. We're going from a ASHRAE class A1 to A2L. If you're familiar with ASHRAE, A or B is the toxicity, so the same toxicity class, but we're going from a 1, which nominally we call non-flammable. The specific language in the standard reads no flame propagation, to a 2L, which we colloquially call mildly flammable or lower flammability per the standard. So we have to adopt for those changes in the flammability classification. And a lot of that is built in as the equipment is designed and being built and rolled out by the manufacturers. And then we need to look at, the places and spaces where it's installed, making sure that is all compliant with codes and standards. And then finally, I think training for the contractors, for the people who are using it, driving around with jugs of it in their hands, installing it, recovering it. A lot of the best practices we've used for things like 410A are not going to change. Some of them are becoming requirements instead of just best practices. But I think overall, the transition from 410 to 454B or R32, it should be even smoother than the transition from 22 to 410 for those who were around back then.
Are there any lessons learned, do you think, that we can take and replicate from that transition from HFC, from HCFC, HF, not my expertise. That the one that for R22.
R22.
Yeah, I know that part is right. When we went from R22 to R10A, 410A, was there anything that we can learn from that transition that we can apply to this transition?
Yeah, two things I would point out. I'm sure that others on the panel might have some. One, don't be afraid and don't panic. 410 was a little higher pressure than R22, and that was a big concern. Like, oh my goodness, we're going to higher pressure. I think as an industry we handled that, got through that, and we went from a pure component to a blend, and a lot of worries early on about blends and how they're going to behave. But I think as an industry we understand them well. We manage well with 410, and 454B is another blend. So. We've been through this before. Some of the challenges are a little different, but as an industry, we're smart people, we're hard workers. We can get through this. No need to panic.
Anybody else want to add anything on to some of the lessons learned we've had between some of these transitions? It's okay if we don't. Okay, I'm going to move on. So my next question I had here was for Devin. So we're going to switch and we're going to talk about the reclamation side of things. So can you walk me through, how does the reclamation and containment of A2Ls differ from HFCs?
Well, the containment, as Chuck said, we've been through this before with 410, where the recovery units changed and the cylinders changed, and we're all still here. We adapted. So this time it's not much different. I mean, it's just the recovery units have to be rated for A2Ls. The cylinder is still just a steel cylinder. All that's changed is the paint scheme, if you will, and how it looks visually. Either has a red stripe with the yellow and gray, or it has a red top with the gray bottom. And the valve has changed from a quarter-inch right-hand thread flare to a left-hand thread. And that's just to avoid putting flammables and non-flammables together, which isn't a big problem, but it should be avoided to begin with, and also just for a general safety protection. From a reclamation standpoint, R32 is part of 410, so it's just as easy to clean, to reclaim and certify. The blends are always more complicated because they can fractionate when we clean them and become off spec. But 32, we're adapting our equipment to the new flammability component. There's not, to be honest, a huge lot of changes. It's mostly electrical. And of course, storage, it depends on the volumes. So fortunate for us, we store our flammable material outside. But if it's internal, it depends province to province how much you can store inside. and in what format, whether it has to be sprinklered or certain shelving. But it's not like an A3 where you'd have to worry about static or chaining cylinders to the floor. It's not too extreme, and especially contractors probably won't have to worry about it at all, because I believe, we're talking hundreds of kilograms before you have to start worrying about fireproof walls and all that sort of thing. So we're preparing for the transition. We haven't seen a lot of it yet, but we will be, and we hope to still provide quality reclaimed A2L refrigerants in the near future rather than just HFCs.
Are you able to share with some of these new changes that you've had to adjust to be prepared for A2Ls then?
Well, we're forming a cylinder fleet dedicated to just A2L refrigerants with the left-hand valve. Our storage hasn't had to change because of its being outside. It's already ventilated. It's just some of the electrical components are just a different class, especially like contactors and so forth. But I mean, the refrigerant's still a refrigerant. It still boils on. You still distill it. You still dry it. You still purge the air out of it. It's just you have to change where that affluent is vented and what's around it to minimize its impact on flammability.
Okay. Trevor, I'm going to jump to you next. So I want to get a little bit of background information about this transition in general. So can you walk me through, why is there an A2L transition in Canada, and why are lower global warming potential refrigerants important to introduce into the Canadian market?
Well, one of the things that I see is that the global warming potential, scientists are looking at the planet and it's heating up. There's lots of factors in behind it. What we're really trying to do is to help the environment. And going forward, this transition is going to happen. It's already happened, because I do a lot of CO2 training, propane training, or A3s, as well as A2L trainings. What I really try to get across with all the technicians and the contractors is, go back to the basics. Go back to what we were supposed to do 25, 30 years ago when I'm in my trainings. So if you always followed the best practices from 30 years ago, it's going to be the same as today. Will there be a few variants? For sure. But we used A3s 30 years ago in refrigeration as we do today. Now there's just some differences. I think it's going to be important as we shift, as the globe shifts for refrigeration and regulations, because I deal with a lot of people in Europe. F-gas regulations, they're ahead of us. And
Yep.
our refrigeration here in North America, we follow the leaders. And as we start to progress, we want to keep up with them. And that's why I keep trying to promote and train, educate safety. As safety, it doesn't matter if it was CFCs, HCFCs, HFOs, CO2. It's all about safety for me.
So 2 points after what you just said. First one, you mentioned about the Europe market, and you have a lot of experience working with them. Very interesting. What are some of the best practices you've learned from talking to those over in Europe that might be something good for contractors, for those in the industry here that can look at something that's been going on maybe a few years more than what we've been dealing with here?
Oh, there's a really good one. I did a TikTok post about 5 or 6 months ago, and somebody from there messaged me and says, because I was showing how to purge. So how to actually purge a line properly. So you open so we don't get any air into the system. So we here in Canada, still not against the law to do a little purge in your hoses. Other countries around the world, you're not allowed to purge. It's against the law to put any refrigerant into the atmosphere. So what do you have to do? Does anybody know? You have to pull evacuation up to the cylinder. Crazy, blew my mind. And so when you go to World Skills, and like we send competitors from Canada, they have to follow the rules in the different countries. It might not be here yet, but I'm like, that is super cool. Is it a pain? It can be a pain from the way we did it. Change is hard, but that's something that I learned from making a TikTok video.
Oh, very interesting. Okay. And you mentioned also in your first answer there about safety. Can you walk me through some of your expertise, experience that you've run across with safety in terms of specific nuances that are different with A2Ls that we've had experience in the past?
Okay, I think one of the big ones, and I learned this from A3s like propane, is that we need a purge now. Before you unsweat anything, really, compressor manufacturers, give you a good example, always wanted you to cut out the compressors. But I was a technician in the field for 10 years in supermarket refrigeration, and I unbraced stuff out of condensing units. And I didn't know that I needed to cut it out like they want. One of the things with A3s, when I started to learn about them from different manufacturers, that you need to purge nitrogen through the system with a leak detector at the outlet and make sure until it's not going off. So it could be 5, 10, 15 minutes purging nitrogen to before you put a torch on there to make sure there's no propane in the refrigerant. A2L should be following that standard as well.
Okay. All right. Awesome. Thanks, Trevor. Okay. So my next question, we're going to jump back up to Chuck next. So what are some of the, okay, we're going to keep going off the safety considerations actually. So what are some of the safety considerations that need to be met with A2Ls and how does it differ from HFCs? Let's see what you say from the manufacturer side of A2Ls.
I would jump on what Trevor said. The best practices that have been developed in our industry for decades are your friend. So purging, good evacuation, ventilation, a safe work area, having the proper tools. We've done a lot of study on the actual flammability properties of A2Ls, and while they are flammable, they're kind of more like the HFCs than they are like propane. So the ignition sources that might be a concern. There's been a lot of work done by industry organizations saying a lot of our hand tools and typical things cannot be an ignition source for A2Ls. You really need something like an open flame to really get these things to burn. The thing I think we talked a little bit about on the reclaim side, vacuum pumps and recovery reclaim machines typically need to be A2L certified or approved. And most of the manufacturers of the equipment have gone through that process. Some of them, it may not have actually been a change, but they go through and test it just to make sure that there's no issues if you start using those with A2Ls. So I think for the people out there working, tools, trucks are going to be pretty much the same until you either are transporting large quantities of refrigerant, like in a box truck, if you're going from a warehouse to a distribution center or something. But the average service van, I think, is going to be fine for transporting them safely. And then, those tools should be certified. But that's the kind of the big changes that I see from the hands-on users of the gases.
Okay.
I want to add to what Chuck said there is because I did a bunch of trainings on fear of CO2, fear of A3s, A2Ls. And one of the things I found at Purdue University, great research university on refrigeration, and some of this work that Chuck does is that 410 ignites. You know what I mean? POE oil ignites. So this stuff already 404, all these refrigerant we use, they can ignite. They're just at a higher temperature. Because I've seen flames come out of pipes before 3 or 4 feet when I was in the field, just learning the stuff. So it's the same safety practices.
Yeah, oil fires can be a real thing. So you can have dissolved refrigerant and oil mist. Those are always something from a flammability standpoint you want to watch out for.
Awesome.
And that's for every refrigerant.
Yeah.
Thanks, gentlemen. Okay, we're gonna shift it a little bit. We're gonna look from a contractor's perspective. So, Victor, we're asking you. So, first question I have for you is: what are some of the challenges that contractors are dealing with in regard to this A2L transition?
Well, I think the one that stands out is just really getting our heads wrapped around what it means, and I think that's the value of today's session is that we're really searching out that one version of the truth. Different trainings that we've gone to, and maybe there's a bias in some to the U.S. market or a different province, hearing slightly different messages. I thought today already the sessions I've sat through have been really insightful. So, really gaining an understanding of, a question I asked in the previous session about room volume, right? B52 and TSA 60335-2-40, which is going to be my password, I think, for something going forward. I can remember it. They treat the amount of refrigerant that you're allowed to put into a space differently. One is based on volume of the space, and one is based on square footage. And it's not an either or; it's a both. You need to comply with both. So I think that was for me. That was an insight already today, taking that into account, and what to do when we're putting an air handler into a small room. So we're residential like commercial contractors, and those are the kinds of scenarios that we're dealing with. Transporting the equipment to site, the amount of pressurized gas that we're allowed to transport in a work vehicle, Again, depends on the province. So I think contractors really need to get clarity around that. And also what counts, right? If you've got your reclaim cylinder and you've got 2 reclaim cylinders now to keep Devin happy, you're going to have one for your 410, you're going to have one for your A2Ls. That's 2 cylinders there. You're going to have maybe a jug of 410, a jug of 32, a jug of 454B. We're going to hit the upper limit of that 100 in Ontario, 150 kilograms that we're allowed to transport. So I think we have to be more conscious of this. That's a really important piece. Is can't just throw it in the truck. We have to really be conscious about what we're doing. But these are best practices anyway. You weren't allowed to carry infinite amounts of pressurized gases before either. So I think this is just going to be that reminder, like Trevor said, that we have to follow these best practices and getting to that one version of the truth. And being clear with our staff also about what the expectation is around safety and compliance.
So what have you heard from some of your members of some concerns they have with this transition to A2Ls, Victor?
Well, I think the first one has been, the transportation of dangerous goods.
Okay.
What are we allowed to transport? And I think, I'll give you an example. Like, let's say you were doing a job, or maybe you've got, a helper has some time and you wanted to restock your shop stock with a couple of jugs of refrigerant. You may want to, reconsider what truck are you sending them in, or versus maybe I should have that delivered from the wholesaler and make it the wholesaler's problem to deliver BG issues if we're moving large volumes of refrigerant. So Maxime will have to worry about that and not make it our problem. But it could be you're finished a job. I remember my days in light commercial, and you're pumping down a bunch of rooftops, and now you've got a bunch of reclaim tanks. And again, like thinking about how are we transporting that back to the shop or back to the wholesaler to be disposed of properly. So that's the first one. The tools, I think, is a big one for us also. Understanding certainly that for reclaim machines, vacuum pumps, and I learned today, it's brushless motor technology. That's the thing, right? We want to make sure that we're not putting a spark near the refrigerant. So tools have been a big one, transportation of dangerous goods. And then that other question that I asked, about, installing it in a small room. So using ventilation grills, combining those rooms together, looking for ways to do that so that, but it's not, it's not enough to say, well, this is a false wall, it doesn't go up to the ceiling. No, we need to have ventilation at the floor because the refrigerants are going to sink, right? So those are the kinds of things we just have to be more cognizant of.
Okay.
We did have a question from the chat. Can A2L refrigerant containers be stored outside and in direct sunlight, whether they're full or empty? So if someone could.
If I can reply. It says it's exact same thing as A1s. So no direct sunlights. That's like number one rule for storing outside. There are ways you can put a temporary or semi-permanent like roof over where you stock it. That's what we do at Wolseley at some places. But indirect sunlight as much as possible for sure.
Yeah, to follow on that, I think all the SDSs say don't exceed, I think it's 120 Fahrenheit. I think that's the temperature most people have, which avoids you having a release event where, some of the new A2L cylinders, I don't know if all of them have, instead of having a rupture disc, now they have a pressure release valve, which will kind of relieve the pressure and then reseat so you don't discharge the entire cylinder. But keeping them under 120 F, regardless of sunlight, not shade, or particularly in a service van or in a vehicle that can get really hot in the summertime, is something you have to watch out for. But standard, same as A1s.
Yeah. The only thing though, if you're storing outside in a temporary shelter, your A2Ls, do not store them next to the A1s or as much as far, not as far as possible, because if you put them inside, you have to be from 20 feet from apart. But so keep that same minding of having them apart as much as possible, and you should be okay.
Can I ask you a question? We've heard about service vans requiring ventilation, like a whirly bird kind of thing on the roof. Does anybody know what the rules are around that? If we're staying under 150 kilograms, do we need to have the service vans ventilated?
I believe so.
I'm gonna for Quebec, at least, the second you have a dangerous material, you have to ventilate it. That's what I know. So even guys with like a 30-pounder, they'll have to have their truck ventilated. Of course, there's a limit, as you know. But no, I don't think there's like a threshold or a limit for that. As for me, it's like you have 1 pound that has to be ventilated.
So it's a provincial. We have to really check with the provincial authority.
Yeah, and you have to have one of those separators behind the driver's bench as well.
The partition. Yeah.
The partition. Thank you very much. Yeah.
Talking about Victor's point there, really reverting back to what the provinces say for each specific regulation when it regards to A2Ls. I know in our last presentation with David, he touched base on B52. This is kind of just kind of spitballing question here. Is there a lot of differences across the provinces? I know this is going to be a very loaded question. Is there a lot of differences across the provinces regarding just into A2Ls? I know that's loaded because it could talk about transportation, storage, everything.
Yeah.
Very different. I recognize that, but Maxime?
Because B52 is for your mechanical rooms.
Okay.
It's not really about storing, transport, or handling
Okay.
A2Ls.
Yeah.
To my knowledge, there's a Canadian fire code for storage, and every provinces needs to apply those norms, and I'll talk about it later on.
Okay.
But I've also been told that it's possible that some more local places have stricter rules, and as long as you respect those, I mean, you should be okay. But it's mostly fire codes for storing.
Okay.
Handling, it's go as the SDS, but there's not much difference to my knowledge. And as for transportation, well, it's mostly provincial to my knowledge.
No, everybody works off the transport of dangerous goods regulations, which is national. So that's the benchmark, and then I believe there's a handful of provinces that could take it a little further, but not many. Most provinces just follow the TDG Act as written. So
another question from the chat is about also I guess how they're stored. Is James said he'd heard that they have to be stored upright, not on an angle shelf. Is that accurate?
I'll take that one.
Okay. No, go ahead.
Yeah. All cylinders must be stored upright, regardless of what refrigerant's in them, because, as mentioned, we have relief valves in Canada, not rupture discs like you'd find on an old disposable cylinder. And if the cylinder's laying down or the liquid's in contact with the relief valve, it could cause a failure of the relief valve doing its job, which is what you don't want, because that's what's preventing the cylinder from rupturing. So all cylinders in Canada must be shipped, stored upright.
And that's been from 20 years ago when I was a technician in the field.
That's right. That hasn't changed, and it will not change.
So there's a format that Honeywell uses. It's kind of like a torpedo where you can store them horizontally. But I don't know about A2Ls. I know about A1s.
Yeah.
But we're not allowed to have those stored in our warehouses. Yeah. But I know they exist. I just don't know.
Yeah, the large bulk tanks, like 1-ton tanks. They're stored horizontally, and the relief valve's designed for that. So it's just on a normal recovery cylinder where you would have a Y valve with a liquid and a vapor connection. The dip tube, the relief valve's at the top of the tank, so it needs to be vapor only exposure.
Okay. So my next question I had was for Trevor. So talking a little bit about installation practices, what are some practices that need to be shifted with A2L refrigerants?
That's a great question. There is a few differences, like the one I talked about earlier about blowing nitrogen through, and I don't even know if that's. I think it's recommended. Once again, there's a lot of these standards out there. We should be following what the standards are and best practices. I've seen over the decades, even myself, I wasn't doing it right when I was in the field because nobody taught me the right way. But doing the right way takes longer. And the technicians are under the gun now around the world. But safety is a big factor. There's a recommendation of like 10 feet around. When I was a technician in the field, I always wanted some space to work. You know what I mean? So sometimes it's hard. In the commercial area, it's a little bit easier. Having the right tools, so the recovery unit and the vac pump. So I know technicians were working on, say, A3s, which is a flammable, for decades now. They didn't even have tools like these rated tools when they were already installing the stuff. Now there's rated tools, like Chuck kind of said out there, that they have to do retesting, like the different manufacturers. For me as a technician, is making sure you have a leak detector on and running, which is something that we didn't always do with 404s and stuff like that. So with A2Ls or A3s, always having a leak detector is important. If you're in industrial, it's no different. If you do industrial, technicians always wore leak detectors walking around, like CO2 or ammonia detectors, to make sure that they're always safe. So I'd say work areas, safe space, PPE, like wear your PPE, your glasses, your gloves, things that it's easy to say, oh, I got to work on a screw and I take my glove off. Got hurt many times doing that, but follow the best practices. And if you don't know the best practices, you can go on ChatGPT and write up what's the best refrigeration practices for HVAC, and then write refrigeration. And then can you refine that? Is there anything I'm missing? Add more prompts to it, and it will tell you stuff how to do proper practices. And as always, follow the manufacturer's instructions. Go to Chemours, go to Honeywell, go to Copeland, Bitzer, Doran, Keep Right, Ref Plus, all these manuals. I can list hundreds of them off. Go to their manuals and read what they say about the A2Ls or the A3s or the CO2s.
Anybody else want to add anything in terms of installation practices?
I'm just throwing that. I think some of our members are already moving more en masse to mechanical connections, moving away from brazing line sets. I mean, that was good to begin with because we avoid oxidation of the pipes, which, is especially when you're dealing with mini split systems and you don't have a filter dryer, you're going to introduce all kinds of contaminants. So that was always a good idea, but I think that we see that more and more as a best practice, and avoiding using a flame. And then again, when it comes to service, I think Trevor mentioned this. I mentioned this in our pre-session. If you have to take it apart again, not using a flame, right? So if it was brazed, we have to make sure that when we're doing service work, that we're not bringing a flame to the line set or any other component. We're cutting stuff out. So I think there's going to be a little bit more. That's not a today issue, but in the next couple of years, as equipment needs to be serviced, technicians are going to have to go, wait, stop, hang on a second. I can't just unsweat this. I'm going to have to do it a little bit differently.
Victor,
yeah,
it's interesting. You said you guys. I mean, the industry is moving away from brazing. So, what technology do you guys use most? Is it the press fits or the push ones, or?
I think that's an interesting question, Maxime, because I think it is all over the place at the moment. And I compared kind of this current transition a little bit to the VHS and Betamax wars, or for those who are a little bit younger, maybe that's Blu-ray and DVD. But we've got two competing refrigerants in the residential, like commercial space, and we've got a whole bunch of different mechanical connections now, right? So whether that's a push fit or it's a crimp style, PEX type connection, certainly I think people are happy to move away from flares, but it's kind of all over the place, and I think to some degree it's a matter of the economics of it, and also what is being carried by the wholesaler refrigeration house that the contractor is comfortable with. Where do they get good support? So I think right now it's kind of all over the place. I don't think we've settled out on a particular solution.
Well, we're talking about install, and let me put in a word for a good stewardship of our refrigerants. Obviously, we have 410 legacy products out there, and systems are going to need to be serviced. That has about 50% R32 in it. The new generation is either going to be neat 100% R32. 454B has about 69% R32. Inadvertently, or if we're tempted to do it because we don't have the right thing, and mixing and matching those things is never good practice. I understand that there's a temptation to do that, but I will say the three reasons I always tell people not to mix refrigerants. One is potentially destroying reclaim value of that, and the reclaimers would like to avoid as much mixed gas coming back to them to make their lives easier. Two is you're creating a new refrigerant on the fly, so your pressure temperature curve is not going to be an exact match. You're never going to have it, totally optimized when you're setting superheat, subcooling. And third, depending on the regulations, you could be creating a new refrigerant, inventing it there in the field, which may not be approved. It may not be in compliance, so you could run into some legal issues there. So, in general, please don't mix refrigerants.
Okay. So we're going to shift a little bit away from contractors, and Maxime, we're going to go to the supply chain side. So can you walk me through how has this transition affected the supply chain?
Yeah, good question as well. I just want to go back to the previous question regarding outdoor storage. A very good other reason to look at is you have to be 20 feet from any vegetation. Oh. Especially in July, for the reasons we all know. So that's about that to add. So on the supply chain on in the distributors, I mean, what we do is we buy boxes, we store them, we sell them, right? That's basically, like, in one sentence what the distributor does. So on that part, it doesn't change much. It's just more offering, more SKUs, more. It's mostly on the efficiency of the processes, and maybe sometime on there's going to be some, of course, some different habits to take, of course. For example, the A2Ls there's two ways to store them. We have cages for that. They look like they're the one we bought, they're yellow. They kind of look like the ones you find at the corner store for propane. Okay, they're used for that. You have to put them 20 feet from any electrical devices as well. You need to, like I said before, if it's stored inside, need to be from 20 feet from A3s, other A1s, other A2Ls, etc. So that's on the storage level. But on the processes of selling it, distributing it, it's not necessarily very different. Even when we reclaim back the cylinders to bring them back to, for example, refrigerant services, there's nothing really different, honestly. It's mostly on the storage part that it differs a lot. There's also an alternate way to store them inside. Is you have to put them on the floor on concrete. You kind of like have to chain them and make sure they can't tip over, and that also nothing could make them collapse. So nothing over them as well, just the roof. So that part changes, and it's not only for, like, the hubs, it's also for the branches as well. That those habits changes a bit, but on the day-to-day, I mean, nothing really is different. It's just another refrigerant to add to your offering. Yeah. And as for I know there's a lot of talks for the quantity limits indoors.
Okay.
Well, the fire code says that non-sprinklered warehouses, your max is at 20 pounds, but when you're sprinklered, it's 40,000 pounds. And to my knowledge, this is regardless of area you have. So no, but supply chain, I mean, it's just a different SKU, honestly.
Okay. So have you heard anything from some of your customers, the tradespeople, the ones around the tools, regarding this? Have you had any concerns that you've heard coming back to the wholesalers? Can you share some of those?
Yeah, I mean, for at least a year, I've been answering questions from different contractors and groups. They're mostly worried. They don't really necessarily have a specific question all the time. They're just like, what's going to happen? What's going on? How is that going to affect our business, or ways to do things, or way to store? And it's not really a joke, but I used to say, well, let's say that company would do refrigeration and air conditioning for commercial and residential. Well, I would tell them, well, you're going to have to buy an A2L truck for your refrigerant. You're going to have to buy an A1 truck for air conditioning and an A1 truck for refrigeration. Then that's because of the limits of the transport for the size, or for the technician, I mean. But the questions that comes more is it really flammable? Is it going to explode if for example, can I put A2L in a system? Can I put R32 in a system that used to have 410A? Well, the answer is absolutely no.
Yeah.
But the opposite is possible.
Okay.
Like, we're going to have probably some efficiency, not issues, but differences. That's something. But no, if it's not as you can't do retrofits to an existing system with using A2L. That's one of the biggest factors. The other one, like I said, was storing and for transport. But when you do services, you don't transport 100-pound cylinders. It's those 30-pounders or 25-pounder you transport, and you can have multiple for different refrigerant. The big quantities, most of the time, they're going to be delivered on job sites for retrofits or for brand new systems. So on this topic, I mean, it's not really a big issue as well. It's just a continuation of what we used to do before. No, but that's pretty much it. They're pretty much worried, like they were in 2010 when we did the switch between 22 and 410A. Everybody was saying, well, the pressure is twice as much. Everything's going to blow up. Well, here we are in 2025, and we're doing another transition. So no, it's mostly people being worried for things they don't know.
Yeah.
Resistance to change.
As we're all pretty used to.
So we have a few questions from the chat. So I don't know who wants to answer. Looking ahead, how long into the future will Canada use the R290 290 heat pump? How long before the R744 heat pumps are the norm?
They are not the norm, but they are some. I know there's a manufacturer down in the US that has a residential CO2 system. I know Carell uses manufactures very small for like for small reefers and small like 1 or 2 doors in supermarkets, very small CO2 systems. I don't think we're that far away from that to be a standard, I mean, or norm.
Also a question, does it affect the stacking of your condenser units inside the warehouse now with the A2Ls?
Can you repeat that?
Stacking your condenser units inside the warehouse, is it different with A2Ls?
Well, it depends. They're usually not pre-charged, the condensers. If we're talking about condensing units for residential, I mean, as like Trevor said, read the manuals. Most of the time, it's going to tell you if you can stack them or not, depending on which manufacturer.
Okay. And the last one was, will Canada make an A2L decision before the year 2030? Anybody know that?
It's politics.
All signs point to yes. Yeah. I would say in the next 2 years. But again, it depends what the US does. Like if a certain person decides that the current regulations don't work for them, then
well, I read an article that the new administration asked the EPA to chill out or slow down that transition for economic reasons.
I read this.
But again, the states can do what they want as well, and Canada is not US.
Yeah, but we typically follow them.
Yeah.
Yeah.
But Quebec can go one way, Ontario can go another way.
Yep.
I mean,
I'm trying to just understand what Michael means when he says, "Will Canada make an A2L decision before the year 2030?" What is that referring to? Like that is that
the GWP. Yeah. So it would be on.
I think that you have an interesting difference in the way Canada and the US have approached this. And speaking to the folks at NRC, for me, it was kind of mind blowing. When in the States, they made the decision to set a GWP ceiling of 700, and in Canada, it falls under the OCHAR regulations, and the decision was not made to come out with an arbitrary line, a cutoff line, but really it's the amount of headspace that you have to import, right? So it's the tonnage or equivalent tons of GWP refrigerant that are allowed to be brought into the country. So the irony is perhaps that the faster we transition to to lower GWP refrigerants, it provides more headspace to allow us to continue to use 410.
Sure.
And so I think what we're seeing is, Asian manufacturers continuing to import 410A product into Canada this year. Certainly, North American manufacturers bringing it in from Mexico. And in a way, I think we've kind of gotten lucky that the Americans are, at least a year ahead of us on this, maybe even 2 years ahead of us. And so we don't have to panic here. I think that's, we're in the States, the equipment shipping, that's what they're dealing with. They've been dealing with it since January. We've got a little bit more time to get used to the idea. It is still going to come. And the idea of, moving to A3s in comfort heating cooling systems, the first systems that we'll have will be the same thing they've done in Europe. We'll have monoblock heat pumps, right? We're not gonna have split system A3 units. Nobody's gonna be putting in a split system R290, R600 heat pump. It'll be a monoblock unit. That'll be the step forward. And we're probably, given the pace that things move in Canada, that's like, I'm gonna guess at least 5 years away. I can't imagine that we're gonna have those in kind of really coming here fast. So I think the panic we can probably take down a notch.
The only thing missing to get to that point with R290 or R600, for example, is to raise the limit per circuit. We're 150 grams right now, so it needs to move up to 300, 500. And Trevor, more maybe about the European market, but for R290, it's in the kilos, I think, the maximum.
Depending where you're at, for sure. I honestly like the propane, and R290 is a great refrigerant. We just got to get the safety things, and if everyone could do best practices, which I know doesn't happen, we could go there a lot faster. I think that's it. And there's safety concerns, but I like propane. Because I do tons of CO2 training, but I like R290. It's a great refrigerant. Just need to have the people to be able to use it safely. And
it's an old one as well. It's an old refrigerant.
Oh yeah, it's in industrial since the 70s and 80s. I've seen with hundreds of pounds. In Europe is the same thing. And here in Canada, we still have lots of propane systems in industrial for refrigeration. So
there's another factor where the transition to A2L, how fast it could be in Canada is, well, for example, if I heard correctly, Ontario gives grant if you use A2L systems or install them. Well, Quebec, no, it's based on performance only, whether you use whatever refrigerant you want. So, I mean, for Quebec, it's not helping. It's not helping the transition. To A2L, that's for sure. But we still sell a lot of 410A because there's no limits for 410A right now in Canada and Quebec as well. So that also affects when we're going to do the whole transition and for it to A2Ls or the complete one.
Okay.
So there's a couple more questions on the chat. What pressures are we looking at in a new A2L systems? Anybody want to take that one on?
It's the same. It's pretty much the same as 410A, I think, 2-3% or something.
Yeah, a little bit lower.
But
essentially, very similar. One of the reasons the OEMs went with a product like 454B or R32 was because it was what they would call design compatible. They didn't have to do a ton of retooling of their compressors, of all their products. A lot of the stuff, and even getting down to lubricants and stuff, could be brought forward. So, the pressures should not vary much. They'll be different, but not in a significant way.
Okay. And James was wondering what A2L residential units are not pre-charged now. Anybody know? I know we don't have the manufacturer.
They're mostly pre-charged to my knowledge, or at least the ones we sell at Wolseley. They all come pre-charged from the containers. And that was one of my main questions to the manufacturers, if they would come pre-charged, since they're being the ones that are built in Asia, for example, they're in the containers for like a couple of weeks in a boat. I mean, I thought that would be an issue, but it's not. So they're pre-charged inside the condensing unit, and same thing as A1s. The interior for a mini split, for example, the wall unit is there's nitrogen in there pre-charged. That's it. That's all. That's all I know on my point.
Okay, there was one more question in the chat as well. So according to the AIM Act of 2020, the USA's next transition is 2029.
Being from the U.S., I'll take that one. Currently, as the AIM Act as it stands today, that transition is a step down. The AIM Act has three parts to it. One being kind of the GWP limits. That's what we call the sector controls. Then there's the handling, reclaim, leak repair. That's the third part, subsection H. But the first part is the step down in production consumption allowances. How much manufacturers like Chemours can manufacture or importers can import, and that has another step down. So important thing, it's not a phase out, so it's not going to zero, but it's going down about 90% reduction from the baseline, which was established many years ago. But that one is scheduled to take another big step down there. I think it's like another 40% step down in consumption, which is why we need the industry to go to lower GWP fluids, so there's enough room to produce all the pounds that everyone needs. And it's beyond air conditioning at that point. Chillers, commercial refrigeration, ice rinks, industrial, automotive, all that's got to fit under there. And all the non-refrigeration applications, aerosol propellants, fire extinguishers, foam expansion agents. A lot of things get covered by the F-gas regulations.
It's the same in Canada. I mean, we have a phase down of HFC CO2 done. It's called a CO2 done allowance. All the manufacturers have one. And it's what you can import into the country. And we're in the second phase down now, where there's a 35% reduction from baseline. There'll be another one in 2030, and then another one in 2035 until we get to a final number of 15% remains of CO2 ton imports. So it's happening on both sides of the border, pretty much in the same calculations, more or less.
Yeah, same level.
So we're all given quota, and then so HFC refrigerants, the A1s that the 410s and the 404s you're typically used to, they'll be around a while. Like they're not going anywhere right now. People are worried about shortages. It's not happening, and it won't be certainly this year, and probably not till 2030 is even when we have to start worrying about it. So the rush to A2Ls is it's justified, but it doesn't. The availability of legacy refrigerants will still be pretty steady, and that should keep prices pretty steady. We won't see what 22 did there a couple of years ago, where it jumped into the stratosphere on price. So there's no panic to worry about legacy refrigerants, just as much as there's not a reason to panic about the flammability issue. So it's all pretty calm right now.
Jump back to our previous question we asked about the pre-charged, and we've answered that they do come pre-charged. James asked a follow-up question asking whether or not that'll affect the way they have to be stored for dangerous goods.
No.
Okay.
For some reason, I don't know. It's not like a cylinder. It's not like storing a refrigerant. It's just storing a unit.
Okay.
Yeah.
Okay, so we have two questions and kind of hitting on the same point, which is concerns regarding the shortage of the R454B down in the States. I've heard that due to a current shortage of R54B, people are charging R454B systems with R410A, and those systems are working. Comments, thoughts, and suggestions? I already know this is going to be answered. Who wants to jump on this one?
I think it's just an important note that there isn't a shortage of 454B. There's a shortage of containment vessels, right? Yeah. So it's not like there's not enough gas to go around. And so for the manufacturers, the OEMs, they have bulk gas. And I saw a note that one of the manufacturers is increasing the amount of refrigerant that they're putting in their condensing units to allow for longer line sets. So the thing is that they were charging them for 10-foot line sets, and they've increased it to 15-foot line sets charge amount. So there is gas; it's just not available in retail or wholesale cylinders for contractors to pick up.
Yeah, and I've heard also from my conversations with those in the industry that is related to also more down in the States, because the States uses disposable canisters, whereas up here in Canada, we do not. And that is in regards to why it's down in the States and not so much up here. Okay. And then I think that feels like that kind of answered Scott's question as well. So we have 5 minutes left. There are 2 more points I wanted to make sure that we touch base today. Keep asking questions, though. Hopefully we can answer at least one more question. But I'm going to go back to some of the questions I've prepped. What was it? Oh, I wanted to ask that question. So this one's for Devin. We talked a little bit about mixing, but I wanted to expand on this a little bit, this conversation. So when you are reclaiming refrigerants and you have to blend refrigerants, are there concerns with mixing A2Ls and HFCs? And can you go into a little bit more detail on that?
There's no concern from a safety standpoint, like no chemical reaction will occur or any sort of thing like that. Mixing refrigerants, as has been mentioned by a few of the speakers, is just bad practice. It's in Canada we are allowed to reuse refrigerant, unlike the States where it has to be reclaimed. And if you're going to mix refrigerants, then you don't have the option of reusing it. As mentioned, the boiling points change, the thermodynamics change because the blend has changed. So mixing is just bad practice to begin with. I wish it was more of a regulation than a recommendation, but I get it happens. You're in a truck and 50 miles from the shop, and you only have one cylinder and 2 different refrigerants. And what are you going to do? You got to get the system back up and running. So about 70% of the gas that comes back to my shop, which is 500 tons a year, is mixed beyond 99.5, which is the standard for fluorocarbon refrigerant. So nothing bad is going to happen to the gas itself or the safety of the person using it. It just saves us a lot of trouble fixing it. So and then we can get gas back out onto the market quicker, and people don't have to worry about shortages or so forth or price increases because of supply. So it's always been a practice, whether it's HFCs or even CFCs or going back that far back. It's just mixing them is not a good thing, but it does happen. It just should be avoided is all.
Okay. The other point I wanted to make sure that we touched base on, this came actually off of our conversation we had yesterday in preparing for our panel discussion today. And it wasn't something I had ever actually known about. And I'm going to need you guys to help formulate this question a little bit because I didn't fully understand what you guys were talking about, which was talking about the oil within the refrigerant. Can somebody help explain a little bit more detail what we were talking about yesterday on that and explain the significance of that?
So I'll start it off. I mean, from the contractor perspective, we're dealing with, either 454B or 32 in residential applications. And the discharge temperature of 32 is higher, uses a different oil. And so the compressor needs lubrication, it's lubricated with an oil. And so the oil for 454B and 410 is the same kind of oil, and the oil for 32 is a different kind of oil, and they're not compatible. So that's the big difference from what are the implications, I think, of that difference. That may be useful for contractors to understand.
Yeah, I would say that they're it's not a compatibility in a chemical reaction. They're going to react together and form concrete or something like that. But the 32 oil was chosen for R32 compressors because of the higher discharge temperature, and you need to maintain proper viscosity and lubricity so the lubricant do its job of lubricating the moving parts in the compressor. So, it's a 32 design, you're using 32, good. It's 454B design, you're using 454B and that oil, you're fine. I think when you get into some of these other scenarios, I'm putting 410 in a 32 system, or I'm putting pure 32, or I'm topping off in a system that wasn't a 32 system, then you could get into some issues where the refrigerant and the lubricant aren't optimized in a sufficient way for the operation of the system. I don't see it as a chemistry issue. It's more an operation of the compressor and the lubrication, maintaining good lubrication.
Okay, thanks, gentlemen. All right, I think we have like 50 seconds left, so we've done a pretty good job hitting our hour time slot. So I just wanted to wrap up, and I want to give a thank you to every single person that's on this panel today. This was very informative to myself, and I'm sure to everybody else that's on this call as well. And I'm going to give a shout out to Trevor's next presentation. I'm going to let him jump out quickly so that he can jump on to his next session and the final session of the day. So please, everyone, make sure that you mosey your way over to the main stage to his next presentation. And yeah, so thank you very much. And we'll be listening in on you, Trevor, soon.
Great. Thank you.
Thanks so much.
Bye-bye.
Bye-bye.